Here we are going to sketch the graph of the function f of x equal 1 over x for x greater than or equal to 1, and use that graph to find the absolute and local maximum and minimum values of the function. So here we have made a sketch of the graph. We know that f at 1 is 1, at 2 is 1/2, at 3 is 1/3, and so on. So the value of the function is decreasing monotonically, and it never stopped decreasing. That is, it's always decreasing. It means the graph is always approaching the x-axis, or is getting closer to it as we go to the right, but it never crosses it, or that is, it never gets a value that is on the x-axis, but is always approaching or getting closer to it. That means that the limit when x grows without any bound, that is, when x goes to plus infinity, is 0, but coming from positive values. That is, the function is always positive. That's the behavior of this function, and we can see clearly that the highest point in the graph, in this case, that is included in the graph is f of 1, which is equal to 1. So f of 1 equal 1 is the absolute maximum value of the function. That is because we have considered a function only for x greater than or equal to 1. For x greater than or equal to 1. And that is, the absolute maximum value is 1, and is attained, in fact, at x equal 1. So we have this result. We have no local maximum for this function. And remember, we cannot consider this the same value as a local maximum because we don't have any graph to the left of the function. So we only consider local streams inside the domain, not in the endpoints of the interval. So in this case, there is no local maximum, and there is no absolute minimum either. Has no absolute minimum or local minimum. And that's because there is no lowest point in the graph. That is, the graph is always descending. It never stopped descending, so there is no lowest point. The thing is that it is descending, but in a way that it will never touch the x-axis, so the descending never stops. And for that reason, there is not a lowest point in the graph, and so there is no absolute minimum. And for a similar situation, there is no local minimum. So we don't have either of those. And in summary, the function has only an absolute maximum value of 1 attained, or that occurs at x equal 1. And that's the characteristics of, or the properties of, the function f of x equal 1 over x for x greater than or equal to 1.